Jaimito is a food delivery robot, and in the future will be autonomous, but now it's controlled with this joystick. We thought this idea to reduce the waiting time when you go a restaurant.
We investigated the state of the art for delivery robots. There's an example of one called Butler, another called Tug that delivers medicines, and also for making the robot we use electronics for all the electronic parts and programming for the Arduino that is inside this robot.
See the internal parts of the robot. The main chassis is made with aluminum, and we have the different components, which are the battery that powers all of the robot, the Arduino that controls the driver, which in turn controls the two motors. We have this voltage regulator to obtain 5 volts from the 12 volts from this battery. This protoboard is only used as a common node to connect voltage and ground. We have here the Raspberry, which in the future will be controlling the autonomous navigation systems. And as we can see, all of our cables are properly labeled for easier troubleshooting.
The robot, we use a PVC foam board, which is the blue part of our robot, a sensor, which is a RP lidar, and the tumbler wheels that we use for our robot to move. And for the base part, for the food, we use a common wood base. And the switches, which is a logic that controls like all the main electrical part of our robot, and the motors and the fuse. As we can see, we turn it on and we start moving it with joystick. Forward, backwards, and turn.
As we can see, Jaimito is a brand new solution for a common past problem. And due to the small size of Jaimito, it can fit in any restaurant or any food court that is required.
The main change of the robot have been in its appearance. A second floor was added that will be used to store the food that will be transported, and with that the lidar was changed of the position to that of the last delivery.
So the first thing we're going to do is modify the .bash RC document. So we open it, and now we're going to modify these last lines in the code. We're going to add them and put the Raspberry IP address, which is 172.20.10.14, in order to put it as the master of the ROS and run the ROS core in our program. After that, we are going to do the next step.
To begin the operation of the robot, we must initiate an SSH connection to it so we can run the ROS core in it. The password is Hola123, and now we are running the Raspberry. We initiate the ROS core. We have to initiate another SSH connection and start running the master launch file, which runs the RP lidar and the mapping, vector mapping.
After run the master project, the lidar begin to check the points and do a map. And to operate the robot, we have to do the raw serial. Wait. Now the Raspberry is connected with the Arduino, and we are going to do a teleop with ROS run. Teleop, quién sabe. Teleop. Okay, now with the teleop we can move the robot with to see the map, we have to run a RBs in the computer. And we have the map of... Well, now to do the actual map, we first have to open the RBs. And we have here the topic map publishing. And since, well, you will be walking around around the robot, the map will be a little badly done. So to reset the points, you just have to put this command, the roast topic pub sys command standard message string, and you send a reset as the data. And once you do that, the map resets and it's a new map.
Manual mode has priority over the teleop mode. So if we go backwards on the teleop mode, but then press forward in the manual mode, the robot will follow this instruction that is forward.